All right, so I was in the middle of this. I wanted to stop so I didn't have to rush it. All right, the question says does not have a good impression of Christians. This does have a good impression of Christians. So what we would have to do is do 1 minus that fraction. Okay, we'll get something, or because it says 2 different ways, or we could add up these 2 numbers and then divide by 435.6. All right, so I'll show you how I'm going to do that on a calculator. Except, hang on, 70.4. Okay, I got to remember that. 435.6. All right, so here, I did numbers. All right, so we were going to do 1 minus. Anytime you have a fraction in your calculator, you need to put parentheses around it. All right, and so we get this guy. Oh, not pushing the right button. Math, enter, enter. And so we get 83 and a 99, like when it's all reduced. 83 out of 99. Okay. Okay, and then if we added up those other 2 numbers, we would get 365.2 divided by 435.6. And then we're going to push math, enter, enter. And let me double check that. All right, 167.2 plus 198. 365.2 divided by 435.6. Okay, I don't know what happened. All right, I added those 2 numbers right here. I get 365.2, and then I divided it by 435.6. That's the total, and then I changed it to a fraction. I still get 83 over 99. Those are 2 ways to find that. What would we say? 83 over 99. Right. So in a sample of 50 people, 21 have O, 22 have A, 5 have B, and 2 have AB. I like to make a little chart. So O is 21, A is 22, 21, B is 5, A, B is 2, and the total is 50. Okay, a person has A or B. Remember that word or means to add? So A is 22, B is 5. So we get 27 over 50. I'm going to make sure we can't reduce that. We get 27 over 50. A person doesn't have A and doesn't have B. So they have neither A nor B. And so what I could do is I could do 1 minus 27 over 50 or A nor B, or I could add 21 plus 2. I get 23 out of 50. So I would get 23 out of 50 if I added the opposite, the complement, or if I subtracted 1 minus the thing. And a person does not have type A. So I can do 1 minus 2 over 50, or I could do 21 plus 22, 5. I would get 48 out of 50. Okay, 48 out of 50 can be reduced. I get 24 out of 25. There's a couple ways to go about the complement. Right? Hospital records indicate knee replacement patients stay these number of days. 15 stayed 3 days, 32 stayed 4 days, 56 stayed 5 days, such and so forth. And we want fewer than 6 days. So that's that. And so the first thing I always do is I go ahead and add it up. 15 plus 32 plus 56, 19 plus 5. And I get 127. So 15 is 3 days, 32 is 4 days, 56, 5 days. Because we don't want 6, we need fewer than 6. So we get 103 of 127. All right, this says at most 4 days. So that's 3 or 4 days at most. So I'm going to do 15 plus 32. I get 47 out of 127. Just checking something real quick. There. So we're still doing like what we're looking for, what we want over the total. Oh, at least 5 days. So that would be 5 days, 6 days, 7 days. So 56 plus 19 plus 5. We get 80 over 127. And it doesn't really see there. All right, law of large numbers. This means when you do your experiment more and more times, like maybe you did it 9 times, and you got 4 and 5, 4 heads and 5 tails, and so your probability was 55 and 44. And if we did it 500 times, we might get 120 and 130. And so let me show you. So then your tails is decreasing, they're going to go towards the theoretical probability. For example, the theoretical probability of a coin is 1/2. 1/2 chance of getting heads, 1/2 chance of getting tails. And so 55 and a 48 versus 44, 52. Then maybe we do it 1,000 times. And this time we get, instead of 55 and 44, we get 0.51. Now that's closer to 50. And then for the heads, we got 0.44, 0.52. And then now we have 0.49. So the point is the larger and the more often that you do your study, your experiment, or your survey, like the more people would ask in a survey, it approaches like the number that you're looking for. And so this in this case is approaching 50%, which is 1/2. All right, so go do your independent practice work and then watch the next set of videos for the next